Hello. Today I want to talk about mathematical induction. Mathematical induction is a way of proving statements in mathematics, and it stems from the ideas of deductive and inductive reasoning. Deductive reasoning is where one starts with a set of rules and makes conclusions with them, whereas inductive reasoning is where one starts with a set of observations and finds a rule set which describes them. For example, one might say that all numbers ending with 0 are divisible by 10, thus 20, 30, and 40 are all divisible by 10. This is an example of deductive reasoning. However, if one saw that 20, 30, and 40 were all divisible by 10, and concluded that all numbers ending with 0 are divisible by 10, then they would be using inductive reasoning. Most of mathematics is based off deductive reasoning, starting with a set of given information or axioms and then creating theorems based upon them. However, mathematical induction is a way of using inductive reasoning to actually rigorously prove something. Let's try finding a formula for the sum of all whole numbers up to some number n using mathematical induction. The first step is to make some observations, so we can list out a few examples. I'll list out some values of n and the sum of all numbers up to n, which I will call S of n. The sum of all numbers up to 1 is 1, for 2 it would be 3, for 3, 6, and so on and so forth. Now that we have the set of numbers, we can try making observations. See if you can spot any patterns in these numbers. Okay, let's see how we might find a pattern that could help us derive this formula. Knowing that repeated addition is often related to multiplication, we can try dividing the sum of all numbers up to n by n. Testing this out, we get this list of numbers, and we can try and find a pattern within them, and I encourage you to try this out on your own. One thing you might notice is that if we multiply every number in our new list by 2, we can get a list of numbers which corresponds to 1 plus the original number. With this realization, we can make our induction hypothesis and say where we think the rule that describes these numbers should be. We think that the original number, n plus 1, should be equal to 2 times the sum of all numbers up to n divided by n. We can then solve for the sum of all numbers up to n and find that it should be equal to n times n plus 1 all over 2. However, we're still not done, because we still don't know that this formula will hold for all numbers. We only know that it works for the ones that we've tested so far. Obviously, we can't test every single number, as that would literally take forever. But we can still prove our hypothesis without knowing exactly why it works. What we will do is prove the formula for the first number, 1, and then show that if it is true for one number, it is true for the next number. This formula obviously works for 1, as we tested it before, and we can still plug it into the formula and see that it works. To show that if this formula works for n, it works for n plus 1, we can compare the sum of all numbers up to n to the sum of all numbers up to n plus 1. The sum of all numbers up to n plus 1 will just be the sum of all numbers up to n plus n plus 1. In terms of our formula, this means that n times n plus 1 over 2 plus n plus 1 equals to n plus 1 times n plus 2 over 2. Multiplying the binomials, we find that n squared plus n over 2 plus n plus 1 equals to n squared plus 3n plus 2 over 2. Lastly, we can combine n squared plus n over 2 and n plus 1, as n plus 1 is nothing but 2n plus 2 over 2. And thus the whole expression becomes n squared plus 3n plus 2 over 2, and we can now see that both sides are clearly equal, meaning that if the formula works for some number n, it will also work for n plus 1. Now that we know our formula works for our initial condition 1, and that if the formula works for n, it works for n plus 1, we can prove that the formula works for all numbers. We can see that since the formula works for 1, the formula will work for 1 plus 1, and 1 plus 1 plus 1, and 1 plus 1 plus 1 plus 1, and this sequence will just carry on. It's kind of like dominoes knocking each other over, in that if our formula works for n, it will work for n plus 1, like how when a domino gets knocked over, it knocks over the next domino. We will see that this will knock over every single domino, and for any number n, we know that the sum of all numbers up to n will be nothing but n times n plus 1 over 2. That was the process of mathematical induction, and shows us that even if we don't understand exactly where a formula comes from, we can still prove that it works. Thank you for watching.